the whole supply chain attack thing made me wonder what's going on with mine. So I changed my GitHub actions a bit. I made the permissions read-only. So, this job, the token can only be used to read. And then instead of getting the action by the version, we get the action by the SHA. So this represents 4v4.2.2. I've got no idea, this SHA is meaningless to me, so we'll put a comment in there. But this means that somebody can't switch what this points to, because the SHA has to match. And the same with these other steps. So these are not specific version. I mean, these are still moving targets. In theory, the builds are not reproducible because these can change, but Ubuntu has a release every 2 years, or I don't know if it's using the 6-monthly build or the 2-year build, but Mac has a release once a year, and it's not exactly moving, but if you want to lock it down more, you could have specific versions, I guess, of these. So persist credentials false seems like a good idea, so stop leaving the credentials around for future steps. Instead of installing any versions, we install specific versions. So it's kind of better than before, but it doesn't really stop an attacker switching out the versions, so we'll do something else in a minute to prevent that. And with catch 2, I've gone from a mutable tag to this specific commit. So it kind of solves the mutable kind of supply chain attack issue, but it's still a live network dependency during the build, so if we get a bit stricter, we could use vendor or use a prefetch dependency cache. You could just have it there already and we're not pulling it. It would be slightly safer, I guess. Oh yeah, I realized I only have one dependency. Apart from the 2 things that build the C extension, we only have one dependency, which is dev dependency, which is PyTest. Well, you hope that PyTest is so central to everything that people would be on top of it and it wouldn't have supply chain attacks and everything. It just seemed like a little bit dumb to have a dependency for such a small thing. So I rewrote the tests to be classic unit tests rather than PyTest. But writing a lot of tests, I'm going to want to use PyTest just because it's so much less verbose. In PyTest, you've got the test function, test detect cast word, and then you do word is cast detect cast word, and then assert that the word is actually one of the words we allow. Kind of dumb test, but it does prove it. Little bit hard coding behavior, repeating behavior in the test. In the unit test, we have a class, test suite, and then instead of just modules and functions, we have this test suite which needs to depend on unit test case, and then we now got the same part as here. Now instead of doing just a normal assert, we do self assert in a bit less magic than PyTest. And that's the whole tests for the Python module. The Python module doesn't do very much right now, so it doesn't have many tests. Like 4 tests, you can get 100% test coverage on the Python module because it's so small. Though. And then I removed the PyTest dependency. So instead of just doing PyTest minus Q, we have to do unit test discover minus S tests minus P and then tell it where it is. We've just removed a third of the dependencies. Reduce the supply chain attack surface. I wouldn't do that for a more bigger package. You'd want to use PyTest. But I said before, just pinning the CI deps to named versions is something. It stops you automatically installing a new version. So if a supply chain attacker adds a new version number, and I won't pick it up automatically, but if they're even more tricky and they replace an existing version, then we want to notice that the hash is wrong. One way we could do this is use pipenv and have a lock file. If you use npm, it's pretty much the same. So pipenv would have a lock file and would have all the frozen dependencies in it. I didn't want to have pipenv, so instead we just use the built-in require hashes. You just give it a file with all the hashes in. So when we build it, we check the hashes of all the dependencies. All right, scikit build core and pybind, which I use, then pulls in all this other stuff. They have to have these SHA hash. So if you hash the packages, they have to be those. When I'm building the cast Python library, it builds the C extension, the C++ extension, using scikit build core, and all the dependencies of that are now hashed. We're a bit more hardened against a supply chain attack because you can't replace these things without these failing. When you hash the package, it has to come out with this value. So if an attacker replaced one of these on PyPy, we'd notice because the hash would be wrong. So pipenv would do this for you, but that's like another dependency I didn't want to install. I mean, that cast doesn't use any dependencies in runtime except for its own C extension, but while building that C extension, it uses scikit build core and pybind to build those. And at least there's not too many. I mean, that's the problem with JavaScript. The dependencies aren't quite fat enough, are they? So they're so... I mean, it's kind of good in a Unix sense of do one thing well. The kind of npm dependency that does one kind of left pad type thing, does one tiny thing. It's easily maintained by one person. I'm the maintainer of left pad, whatever, but in npm you install one thing and then you've got like 2,000 things in your known modules folder, each of which is potentially a package that can be replaced and try to run things on your system to steal your crypto or whatever. So with Python it's a little better because the dependencies are a bit fatter, so they don't tend to bring in as much stuff, although these two dependencies have brought in a lot of stuff, but they're all quite common stuff.